this chapter is prepared for the 10th standard for board exam, CBSE, as well as for the state board exams. The first chapter in science is chemical reactions and equations. In this topic, just I describe each and every point very clearly, and at last of the chapter, I put you or I give you the best questions, whatever the questions it is going to be asked in the board exam, in the forthcoming board exams. Correct? So at first we have to come to know what is chemical reactions. Okay? And against the definition of chemical reaction, just I have written here that a chemical, whenever a chemical change occurs, we can say that a chemical reaction has taken place. As for example, when magnesium is burned, it gives magnesium oxide. That magnesium burns with white dazzling flame. Okay. As we know that any object burns in presence of oxygen, that is why in chemical reaction we represent the chemical reaction in such a way. Magnesium plus O2, that gives magnesium oxide. This magnesium oxide is obtained to us as white acids. Okay, means it's the color of the acid is white. That is why the activity, this activity is written in words like this: magnesium ribbon burns with a dazzling white flame and changes into a white powder. This white powder is magnesium oxide, and this is the magnesium oxide, whatever we obtain here. Now in second activity, you must know that at present, what are we showing? We are showing the activity of a chemical reaction, correct? Because previously I defined the chemical reactions in such a way, whenever a chemical change occurs, we can say that a chemical reaction has taken place. Here we see that magnesium turns into magnesium oxide, means there is chemical change. Now see, in the second activity, just we define here that when zinc granules react with dilute hydrochloric acid or dilute sulfuric acid, in both the cases, hydrogen gas is liberated and the corresponding chloride or sulfate is obtained. If we react zinc granules with dilute hydrochloric acid, we get zinc chloride, and when zinc granules is reacted with dilute sulfuric acid, we obtain the zinc sulfate and hydrogen gas. In this case also hydrogen gas is obtained, correct? So there is changing, there is chemical change. That is why we tell that it is a chemical reaction. In other activity, in third activity, we see here that we take lead nitrate solution in a test tube and add potassium iodide to this, correct? See here, lead nitrate, PbNO3 whole 2, and potassium iodide. When it reacts, it gives potassium nitrate and lead iodide, PbI2. So there is chemical change, that means a chemical reaction has taken place, correct? Now, in the other one, just in other topic, just we define here. So what do we conclude? In the previous activities, what do we conclude? In these observations, we conclude that during a chemical reaction, any one of the following change can happen. Either there is change in a state, correct? There is change in color, there may be evaluation of a gas, or change in temperature, or these all can take place at a time also in a single chemical reaction. Correct? Now see, the next point is chemical equation. So just I define the chemical equation like this. When we represent a chemical reaction in its symbolic form, it is called a chemical reaction. Chemical reaction I defined earlier, at present only. Now I define here chemical equations. So what we write here, when we represent a chemical reaction in its symbolic form, it is called a chemical equation. Now see, in this chemical equation, a word equation also comes. If a chemical reaction, we write it in the form of words. Means whatever we write here, magnesium plus oxygen, when magnesium reacts with oxygen, it gives magnesium oxide. So in words we have written, correct? This LHS site is called reactants and RHS site is called product. Means when two or more than two substances, that substances may be either element or compound. Okay, they react. Then we obtain the new substance, new element or compound, whatever it is. So the new substance is always called a product. Now see, our next point is writing a chemical equation. Correct? A chemical equation we cannot write always in two words. Means a word equation covers a big space to write. But a chemical equation, when we represent it in symbolic form, it covers a small distance to represent it. Correct? Now see, in this chemical equation, when we represent the chemical equation in its symbolic form, if it is not balanced, then it is called a skeletal chemical equation. So whatever we write here previously, see here, just I am going to write what the chemical reaction occurs. The chemical reaction occurs, whatever it is written in words. Okay? Now see, next one. In next topic, just I write here, when magnesium reacts with oxygen, it gives us magnesium oxide. We write here in such a way, this is not balanced. Because see here, on the LHS side, magnesium is 1 in number. On RHS side also it is 1 in number. But here on in case of oxygen, on LHS side it is 2 in number, and on RHS side it is 1 in number. So naturally it is not balanced. It is called a skeletal chemical equation. This a skeletal. And when we balance it by heat and trial method, we generally balance the chemical equation by a simple method that is called heat and trial method. Then when we balance it, it is called a chemical reaction. Correct? It is also a chemical reaction, but it is a skeletal chemical equation. Now, see, how can we balance the chemical equation? Correct? See, the next topic is here. The next topic, according to your syllabus, I teach here each and every point. Whatever the point is written, balanced chemical equation. Okay? Why the one question stands here, why do we need a balanced chemical equation? We need a balanced chemical equation because chemical equation always follows law of conservation of mass. Means total mass on the LHS is always equal to the total mass on the RHS. On whatever the compounds or elements are present. On LHS side and RHS side, their total masses must be equal. Correct? Means we can tell that law of conservation of mass states that total mass of reactants is always equal to total mass of products. Correct? Now, one question just I put before you, that why do we need a balanced chemical equation? We need, the answer here it is written by me, that we need to balance a chemical equation because a chemical equation always follows the law of conservation of mass. Correct? What is the law of conservation of mass? Just I defined earlier. So, see here, in word equation of activity third, what was the activity of third? It was when zinc granules reacts with dilute sulfuric acid. This sulfuric acid must be diluted so that zinc granules may react very quickly. It gives zinc sulfate and hydrogen. Means hydrogen comes here as a gas. Correct? So a word equation we write the against the activity of third. Now see, that word equation is represented in its symbolic form, and we write the chemical equation like this: zinc plus S2SO4, that gives zinc sulfate and hydrogen. Now we check whether it is balanced or not. If it is already balanced, then we have to leave it as usual. Okay, this is already a balanced chemical equation. But if there is need to balance it, we will have to balance it by heat and trial method. Correct? Now, what is heat and trial method? Just you have to concentrate here. If you will concentrate here, you will come to know about the method and you will never do any mistake. Correct? So, the simplest method is heat and trial method to balance a chemical equation. What do we do here? We have to write here element, number of atoms, okay, on LHS side, number of atoms on RHS side. So whatever the elements are used during the chemical reaction, okay, whatever the chemical reaction we have to balance, just we see here that zinc is there, hydrogen is there, sulfur is there, and oxygen is there. Now, what is the number of atoms on LHS side in zinc? It is 1. On RHS side also it is 1. Similarly, we have to write all these elements, the number of atoms on LHS and RHS side. And we see here that it is already balanced. So, just I have written here, there is no need to balance it. The reaction is already balanced. Now, we move on. Question second. Okay. A question put before you, iron, when reacts with acetine, okay, it gives iron oxide and hydrogen. Now see here, whatever the elements on LHS side it is used, iron, hydrogen and oxygen. Just I mentioned here iron, hydrogen and oxygen. Number of atoms on LHS side, in case of iron it is 1, on RHS side it is 3. Hydrogen on RHS side, number of atoms is 2. On RHS side, it is 2. In case of oxygen, it is 1 on LHS side and it is 4 on LHS side. Now, we see here that number of atoms in case of iron and oxygen, these are not balanced. Correct? Now see, what do we do here? We do here according to the rules. Correct? Now see, what do we? Now, in heat and trial method, number of atoms of the corresponding elements on LHS side and RHS side we have written already. Now, we have to balance it, correct? Now we have to balance it. How can we balance? We see here that in the case of oxygen, it is not equal. Now, if we want to equal that oxygen, naturally we have to multiply here by 4, then we will get 4 as the number of atoms in case of RHS. Now see here, how do we clear here the concept regarding this. See, this clear concept just I put before you. So, which compound we have to select? See here, in this reaction, see here, in this reaction, we have to select that very compound in which the number of atom is maximum. Now see, this iron has 3 atoms maximum and oxygen has 4 atoms. So naturally we have to select this Fe3O4 at first, correct? That is why just I mention here, see, just I mention here that we select the compound which has maximum number of atoms. Here we select Fe3O4 for our convenience. Okay, for our convenience, we select which compound? Fe3O4, because here number of atoms is maximum in case of oxygen as well as in case of iron. So at first, we have to balance the number of oxygen. Okay, so number of oxygen atom on LHS side is present in water and it is 1 in number. On RHS side, oxygen is present in Fe3O4, and what is its number? 4. So naturally, to get it 4, we have to multiply it by 4. That means we have to put at the starting of the water. So just I have written here, iron plus 4H2O, that gives Fe3O4 plus hydrogen, because there is no changing. Okay, here on RHS side we do not change. We change to balance the number of atoms of oxygen, we put here 4 in case of water only. That is why I mentioned here. Correct? Now if we put 4 here, number of hydrogen gets changed. Here it is 8 in number, here it is 2 in number. So now we have to balance the number of atoms of hydrogen. Here it is 8 in number. When we put 4 here, hydrogen becomes 8. But on RHS side, it is 2 in number. So naturally we have to put here 4 to get it balanced. That is why I put here 4, but leave all the rest terms as usual. Correct? Now, other is also not balanced. That element is iron here. That element is iron here, which is not balanced still. Correct? Now see, iron is present 1 in number on LHS side, and in Fe3O4 we observe that iron is 3 in number. Now naturally, to balance this as the RHS side, we have to multiply here 3. That means we put 3 here. 3 here in the reaction. See here. Just I put here 3. Okay. And there is no changing at last in the atoms of the iron. Correct? Naturally, this, whatever the equation we get now, it is a balanced chemical equation. And the method, whatever I describe at present, it is heat and trial method. Correct? Now see. Now against the other. Just I do here. Okay. Now see, according to the exercise here, whatever I taught you at present, these are according to the syllabus only. Correct? The heat and trial method just I described here. It is given in your syllabus. The next also I have described the whole, these, okay, these, just I described the same method, whatever it is given in your syllabus. Correct? Now see, in third, just I define in such a way only, whatever the topic is given in the syllabus. Correct? Up to this point. Now see here, sometimes the reaction conditions sometimes reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below of the arrow in the equation. Suppose carbon monoxide when reacts with hydrogen at at which pressure it is 340 atm. Atm means atmospheric pressure, correct? So it is written, either it is written at the on the above or below. Above of the arrow or below we can write here, and it gives us CS3OH. Okay, CS3OH. When carbon monoxide reacts with hydrogen at the pressure of 340 atmospheric pressure, it gives us methyl alcohol, CS3OH. So, a state, we mention in this reaction the state of the compound or element. Here, it is in liquid state. That methyl alcohol is in liquid state. Here, hydrogen is in gaseous state. Carbon monoxide in gaseous state. As we know that carbon dioxide as well as carbon monoxide is in its gaseous state. Now, when these react, it gives methyl alcohol. Now, in second reaction also, this is the reaction of a photosynthesis. Whatever you already had learned in junior class also. Okay, but the complete reaction or the method you study here only. When carbon dioxide reacts with water in presence of sunlight and chlorophyll, okay, it gives glucose C6H12O6, oxygen gas it liberates, and water is obtained. Okay, so photosynthesis reaction, generally we tell that in bio subject we study that roots take the water and it sends to the leaves. Okay, in leaves chlorophyll is present, and in leaves stomata is already present. That stomata respirate carbon dioxide from the atmosphere, correct? That respirate carbon dioxide, and water is coming from the soil, and that water is being absorbed by the roots of the plant. So when in presence of sunlight and chlorophyll present in leaves, and in daytime the leaves of the plant get sunlight. So in presence of sunlight and chlorophyll, that carbon dioxide and water reacts and it forms glucose and oxygen and water. That oxygen plant release in the atmosphere. That is why we tell that whatever the oxygen plant is releasing, that is pure in form, correct? So just we see here that some conditions like sunlight and chlorophyll, these conditions are mentioned in the on the above or below of the arrow, correct? That is why it is written here. Now next, see here, few questions. Whatever the topic we have learned at present till now, that these questions are based on the taught topic. Okay, the first question, it is given that why should a magnesium ribbon be cleaned before burning in air? Just I put you answer. Okay, the second, write the balanced equation for the following chemical reactions. In word equation it is written. This is the chemical reaction written in words, means a word equation is written. We have to write it in its balanced form. Okay. Now in third also, write a balanced chemical equation with a state symbol. A state symbol means what do we know? A state symbol. See here. In this chemical reaction, a state symbol is written here. Carbon monoxide in gaseous state. This is the state symbol. This is the state symbol of the element or compound, whatever it is. Here also a state symbol is written. In this chemical reaction also, iron is in solid state. That is why a state symbol is written here. So, in this question, inside question, given in the book, write a chemical equation with a state symbol for the following reactions. In words, it is written. Whatever the chemical reactions occur here, it is written in words. Now we have to write it into its symbolic form and write its state symbol also. Correct? Now just I am going to describe how can we write the suitable answer of these questions. Correct? Kindly see here. See, just I have written here, page number 6, NCERT question solutions. Why should, first question, as you remember, why should a magnesium ribbon be cleaned before burning in air? Now, what we write here against the answer, magnesium is active element, correct? Which reacts with any substance present in the atmosphere, and a coating is present on its outer layer, which prevents it from complete burning in air. To overcome this, we clean it by rubbing before burning. Now, in second question, just I put the question second. Write the balanced equation for the following chemical reaction. Hydrogen, we have to write in symbol, its symbol, then we can balance it. Chlorine, also we have to write in symbol, and the molecular formula, because it is a compound, so it will be written in its symbolic form, hydrogen chloride. See here, just I have written here, hydrogen, when reacts with chlorine, it gives hydrogen chloride. Correct? Now we have to balance it. Now see here, the complete method, heat and trial method, we do in rough, but at present, how can we balance it at once? See here, on LHS side, hydrogen is 2 in number. On LHS side, on RHS side, it is 1 in number. Previously, it was 1. Now we have to make it 2. Naturally, we have to put 2 here. We can't put here 2 in the molecular formula, or in, see here, at present the hydrogen has the molecular formula as S2, correct? Chlorine has the molecular formula as Cl2, because the symbol of hydrogen is S and symbol of chlorine is Cl2, Cl, and its molecular formula is Cl2. It gives hydrogen chloride, correct? Now, in second, it is written that barium chloride reacts with aluminium sulfate. It gives barium sulfate and aluminium chloride. Now, how can we write this? Now, see here, when barium chloride reacts with aluminium sulfate, it gives barium sulfate and aluminium chloride. Now, how can we balance it? See here, barium is 1 in number. On RHS side also 1, it is 1 in number. That means already balanced. Now, chlorine is, see here, chlorine is 2 in number. Here, chlorine is 3 in number. So, how can we balance it? We see here that 2 and 3 can be balanced if it comes 6 in number. So we put 2 here and here 3, correct? Now the chlorine has become 6 and here also chlorine has become 6 in number. Now we should move here. In case of sulfate, we see here that it is 1 in number, here it is 3 in number. That means to make it 3 on RHS side, we put 3 here, correct? Now we see that all the elements, the number of atoms is same, correct? Same case, Same case arises in case of sodium and water. When it reacts, it gives sodium hydroxide and hydrogen. Okay, so just I have written these answers against the question of whatever the questions are given in its form. Now, the next topic is type of chemical reactions. Okay, just I describe here types of chemical reactions. During a chemical reaction, old bonds break and new bonds form to produce new substance. What happens during the chemical reaction? Whatever the bonds are present previously, it breaks and new bonds form and new substances form there. Correct? See here, as for example, when sodium hydroxide reacts with hydrochloric acid, it gives salt and water. Correct? It is also called a it is also called a neutralization reaction because it is basic in nature. This compound is acidic in nature. It neutralizes each other's effect and gives salt and water. it is an it is a neutralization reaction. Now see, next, combination reaction. Just we are going to read here types of chemical reaction. The first type is in your syllabus, according to your syllabus, the first type of the chemical reaction is combination reaction. See, such a reaction in which a single product is formed by two or more reactants is known as a combination reaction. See here, calcium oxide when reacts with water, it gives calcium hydroxide, and heat, it also evolves heat. During a chemical reaction, when heat evolves, then it is called exothermic reaction. Okay. On the other hand, if a chemical reaction needs heat, that means here if we write here heat, that means the chemical reaction needs heat, then that very chemical reaction will be endothermic reaction. But here it is exothermic reaction because during the reaction, at last, heat evolves. Correct? Now see, we see here, according to the definition, combination reaction, two compounds form a single compound. Correct? Because the definition is as such a reaction in which a single product is formed by two or more reactants is known as a combination reaction. Correct? Now, it is exothermic, just I have written here. Now, burning of natural gas is an exothermic reaction because the exothermic reaction word already appears here. So, some exothermic reaction just I describe here. Burning of natural gas when methane, because methane is a natural gas, when it burns, that means it burns in presence of oxygen. It gives carbon dioxide, water, and it releases heat. Here also heat is released. Okay, that is why it is exothermic reaction. Respiration is also an exothermic reaction. How can we tell that? Respiration is also an exothermic reaction. You must know, this is the main point. During digestion, food is broken into simpler substance. Most of the substance, whatever we eat, contain carbohydrates. Whatever the substance we eat, maximum are carbohydrates. That is why that carbohydrate provides us energy. So these carbohydrates are broken down to form glucose. Okay, this glucose combined with oxygen during respiration. When we respirate oxygen, that glucose combines in the cells of our body and provides energy. The special name of this reaction is respiration. Correct?